Hello grade 10s, welcome back to another video with me, Miss Martins. Today we're going to continue on with the atom, grade 10 chemistry, and we're going to be looking at how to represent an element on the periodic table in its AEZ notation. Now, this is just a way to represent the element on the periodic table along with its atomic number and its atomic mass number. It's a notation, it's just a way of writing something. But in order to understand how to write it in the AEZ notation or the EAZ notation, however you say it, you need to understand what the E is, you need to understand what the Z is, you need to understand what the A is. Now, this is what your periodic table looks like that you should be receiving in your grade 10, 11, all the way up to grade 12 chemistry exams. I actually took this from the grade 12 exam guidelines, and your grade 10 and 11 teachers should be using the exact same periodic table. If you look at the periodic table, it has a key on the periodic table. The key over here, it's a little block that shows the copper element, the symbol, so you see symbol, Cu, then the top number, so 29. That is what we call the atomic number, and the bottom number over here, 63.5. That is the approximate relative atomic mass. The sideways number, which we deal with at a later stage, is called electronegativity. The two numbers that I want you to focus on when looking at the periodic table and in this lesson is the atomic number at the top, the smaller number, and the relative atomic mass, which is the bigger number. Now, on this periodic table, atomic numbers at the top, relative atomic masses at the bottom. However, if you Google periodic tables or if your teacher uses a different periodic table, they might be switched around. It depends on the periodic table. But what will always be true is that the atomic number will always be the smaller number. The atomic number is always the smaller number, doesn't matter where it is, and the relative atomic mass is the bigger number. Now, if you watched the previous video, you should know what the atomic number is, what it represents, and what the atomic mass represents. So just as a recap, if you take a look at sodium from the periodic table, you will see that it has an atomic number of 11 and a relative atomic mass number of 23. In a neutral atom, so not an ion. An ion is if something gains or loses electrons. So if I'm speaking about a neutral atom, 11 will be the number of protons as well as the number of electrons. So this means that a sodium atom has 11 electrons and 11 protons. The relative atomic mass, the number at the bottom, is basically, it's the mass of the element, and it consists of the number of protons and the number of neutrons. So this number here, 23, is the number of protons plus neutrons. What this means is if I want to find the number of neutrons, I take the big number, 23, minus the small number. Okay, 23 is protons plus neutrons. That means if I subtract the protons away from the 23, I'm left with the number of neutrons. So the number of neutrons in a sodium atom is 23 minus 11, which is 12 neutrons. So that's what the numbers mean. Now, in this video, we're just going to be focusing on how to place it in that notation. This is a very nice, important summary slide. Take note how over here, I've written it as EZA. However, they could write it as EAZ. So the A might be at the top or the bottom. The Z might be at the top or the bottom, depending on what they ask, depending on how they give it to you. But E will always be element. So it's the symbol of the element. So in order to get that, you look at the periodic table and it is one of the symbols. So one of these, like for example, Mn or Fe or Co, it's the symbol of the element. That's E. Z is what we use to represent atomic number. So I wrote there that it's the little number, it's the number of protons, it's also the number of electrons in a neutral atom. So protons, electrons. A is the atomic mass number. Now, how I remember the difference is atomic number Z, the mass number is A. A for mass. The A in mass, the A. That's how I remember it. It's the big number, A, big number. It's the total number of neutrons and protons together. Right. So if I had to ask you to write sodium, because we were speaking about sodium, in this notation, let's actually do it in this notation. EAZ. How would it look? So there's the question. I've also pasted sodium from the periodic table. Sodium's in the first group. That's where I found it. So they wanted an EAZ notation. So E is the element, the big symbol for the element, which is Na. At the top, they want the atomic mass number. Now remember, the atomic mass number is the big number, 23. So we're going to put 23 at the top. Then they tell me that they want Z at the bottom. Z is the small number. Z is the atomic number. So 11 goes at the bottom. And that's your answer. That is how simple this is. Just keep in mind that if they wanted me to work out the number of neutrons, then you take A minus Z, or big number minus small number. Atomic mass number minus atomic number. Let me give you some to practice. Here is an activity for you to practice. Now, when you read the questions, and I want you to do this in your exam as well, please, grade 10s, is read carefully. Here they say give the E, A, Z notation, where A, the bigger numbers on the top, Z, the smaller numbers at the bottom. Here they say give the E, Z, A notation. Z, the smaller number, is at the top. Okay, try those quickly, then pause me, unpause me to mark. Right, for carbon, now it's EAZ notation, so carbon is my E, it's my element, big C. A is the atomic mass number, it's the bigger number, it's 12. And Z at the bottom is your atomic number, it's 6. There we go. What about oxygen? Oxygen, E is your element, big O for me. A is your atomic mass number, it's the big number here, it's 16. And Z is your small number, it's 8. What about sodium? So sodium, now read the question. Question 2 is different. They want the elements, so start off with the elements, Na. Then they want Z at the top, the small number at the top. So we've got 11 at the top, and they want A, big number, at the bottom, 23. Then potassium. Potassium is K. They want Z, the small number, at the top, and they want the big number at the bottom, 39. Just remember, if I had to ask you how many neutrons are in potassium, how would you do it? You would say 39 minus 19. So you would get 20. So let's do this past paper question, which is related to this video and yesterday's video. In this question, they're giving me Al, which is the aluminium atom. This is an atom. It's neutral. It's not an ion. It's not charged. It's an atom. It's neutral. This is the aluminium ion. It's an ion. It has a charge. It's a cation. It's positive. So just take note of the difference. Aluminium atom is neutral. There's no charge. Aluminium ion is charged. The number of protons, whether it's an atom or an ion, will always be the same. Let's take a look at our periodic table. Aluminium can be found over here. Okay, so it's Al with a little 13 on the top and a little 27 on the bottom. 13 is the number of protons. Now, as I mentioned, the number of protons will always stay the same. So that means that over here, my answer for protons is 13. My number of electrons for the aluminium atom is the same as my number of protons, 13. Remember, I mentioned earlier that this is Z. Remember, the small number is Z. And Z is equal to the number of protons in an atom, but it's also equal to the number of electrons in a neutral atom. That's what this says here. So it's the number of electrons in a neutral atom, but it's also the number of protons. That's very, very important. Then we've got the number of electrons in this ion. Now, as I mentioned in the previous video, if you have an ion of Al3+, what that means is that this atom, to become this ion, has lost 3 electrons. Now, first of all, how do I know that it has lost electrons and it hasn't gained electrons? If you lose something that's negative, electrons are negative. If you lose the negative, you become positive. So if I get rid of negative stuff, I become positive. That's why it's positive. And I haven't lost 1 electron or 2, I've lost 3, which is why it's 3+. So the aluminium atom hasn't lost any electrons, it's got 13 electrons. However, the ion has lost 3 electrons. So it hasn't got 13 anymore, it's got 10. Then they say mass number. Now the mass number is the big number, it's 27. And for the ion, it's still 27. And the atomic number is the small number, it's 13. and 13. I hope that's been a helpful lesson. If you don't really understand this lesson, you're going to want to go check out the one before this. Check the links in the description box below. For more lessons like this, please subscribe. I can't wait to see you in another video very soon. Bye, everyone.